Okay, today we're going over 5.4, which is graphing polynomial functions. So we're going to start with just some of the characteristics. So the first thing is that the graphs are continuous, which means they're smooth with no breaks. So you should be able to draw it without lifting up your pencil. The next thing we're going to talk about is that leading coefficient. The leading coefficient is the number, so it's not a variable. Coefficient is a number in front of the highest power of x. If that is positive, then the graph is going to open up to the right. So that means this: as the x's are getting bigger, remember f of x is just another name for y, so are the y's. So I'm going to draw a quick example of that right here. So if my leading coefficient was positive, whatever point was like over here on the right, the graph would be going up, okay? And then the other one says if your leading coefficient is less than 0, or if it's negative, then the graph will go down. So again, this is all dealing with the right. So that's the right side of the graph. This is the left side. This is the right side. And then the last little characteristic we're going to go over right now is the degree n. So the degree is the same thing as the power. Okay, so this is going to be, I'm going to write this, the highest power of x. And whatever the highest power of x, so for example, this one is 3, the number of turns the graph will take will always be that number minus 1. That's the maximum number of turns. It can take less turns than that, but it can't take more. So when I'm looking at the powers of x in part B, I'm looking for the degree, which is that power right there. Okay, so we're going to work with these real quick just to make sure that we get that. So this one right here, what I want you guys to do, the max number of turns is going to be 3 minus 1, because here's the 3, and we learned up here it has n minus 1 turns, so that one has 2. And then for right end behavior, I always want you guys to make this little plus minus chart. So as the x's are going to positive infinity, we're going to look at this leading coefficient right here, which is 1/2. Is that positive or negative? That's positive, so the graph is also going to go up. So then we would say it would go to infinity, because it's going to go up forever. Okay? Let's look at the next one. The highest power of x is 2. So the maximum number of possible turns is 2 minus 1. So this graph will only take 1. And if you look, it's an x squared graph. So that's a parabola, and a parabola only makes 1 turn. Now for the right end behavior, I keep telling you guys to do this plus or minus. And again, this right here is -1. So we're looking at 1/2 on this guy, but the number in front of the highest power of x here is -1, and that's negative. So guess what the graph is going to do? It's going to go down forever. So we're going to write negative infinity. Now when we get to the next example, it looks a little tricky, but it's not really going to be that tricky. So what you're going to do is, we need this first term. And this is in factored form versus being multiplied out or expanded form. So what we're going to do is we're going to take the first term in each one and multiply. So x times x times x times x. So that would be x to the 4th. And then if we had to multiply that out, that would be really annoying. But thankfully for these questions right here, we only need to know the first term, which we would find by multiplying the first terms all together. So we're good. So this is the 4. So our max number of turns is 3. And then for our right end behavior, we're just going to look at this number in front right there, which mathematicians are lazy, so they don't write, but that's a +1. So this graph is going to go up, up, up forever. So we're going to write infinity on the right-hand side of it. We'll talk about the left-hand side in a minute. Now this one right here, we need to write it in expanded form rather than in factored form. So we're going to take the negative and multiply it by x and another x. So that's negative x squared. And we know that there's a whole bunch of other stuff after this, but again, we don't need to concern ourselves with it right now because we only need that first term. So max number of turns is 2 minus 1. So that one's going to be another parabola opening down because it's negative. So right-end behavior, we're going to see that that's a negative 1. So it's a minus. So this graph to the right would be negative infinity. Okay? All right. So now we're going to move on to figure out what it does to the left. So if the highest power is even, then we are going to go and follow the same behavior to the right and left. So if it's even, the right end behavior and the left end behavior do the same thing. So they match. Okay? So if the highest power is even, they match. Okay? What happens when the highest power is odd? They don't match. They do opposite of each other. Okay? They do the opposite. Okay, so now we're talking about the left, but in order to find the left, we have to know what it's doing to the right. So that's why we have all this stuff up here that we did. Okay, identify the left and right end behaviors of the graph. So right end behavior is always plus minus. So we're going to take that and we see that this is the leading coefficient. So that's negative 2, which is negative. So to the right, this is going down. All right. Now for left end behavior, it's not plus minus, it's even odd. Okay. And when we're doing even odd, we're looking at that number right there. So 3 is an odd number. And it's nice that actually is an O because we know if it's odd, then we do the opposite. So this graph would be doing the opposite and going to positive infinity. So this is not what the graph looks like, but I'll just show you kind of what we're getting to. To the right, the very most X-intercept will go down, and to the left, it'll go up. There'll be something in between here, but for now we're practicing how to find what it does as it's getting bigger and bigger. Okay? All right. Right end behavior here. Again, I'm going to do it over here. Plus, minus. So right end behavior is always plus, minus. So this is the number in front. It's always the first thing that you see, and in this case you don't see, but it's not the power. It's the coefficient. So that's positive 1. So this is going to go to infinity. And then the left end behavior, we look at even and odd. So you're not looking at that 1. You've already used that number, so you're going to look at that number. So that's 4, which is an even number. And if they have the even, they match. So this one was infinity, so its match is also infinity. So what this graph would look like is the right and left would both be going up, and it probably does something like this in between, but something like that. Okay, so you see how these are continuous and they're smooth curves. That's what we're going to be doing to look at these right here. Okay, so the next example says to use a graphing calculator. So if you want to, not if you want to, go grab a graphing calculator if you haven't already from the tray. Grab your roster number so that you can make sure you know how to do this, because this kind of stuff shows up on the test. So here is a really old graphing calculator of mine. This is the one I keep at home. And it says, using a graphing calculator, identify the domain and range and end behavior of the polynomial function. So what we want to do first is hit zoom and then pick 6 because I want it to be from -10 to 10. Some of you might have a graphing calculator that has been used for stats. So please do not hit the button on the back. Pencil lead gets broken in that. What I need you to do instead, to reset a calculator, you're going to hit second, then the plus sign down here, and then 7, 1, 2. And then it'll clear it for you. And then when you hit zoom 6, you should have this if you didn't already, with no graphs in it. Okay, so everyone, to type in an equation like this right here, we're going to hit the y equals button. And this says x to the third, so the x button is right next to the alpha. There's actually 4, but we're just going to hit it once and the x will come up. And then we're going to use this caret symbol. That upper arrow symbol below clear is called the caret. And then the 3. So that's telling the calculator to do x to the third power. And then we're going to hit graph. Okay, so this graph right here goes, comes up from -infinity and goes all the way to +infinity. So when we're talking about domain though, domain is how wide, are there any boundaries on how wide my graph goes? So the graphing calculator looks like it's kind of stopping here, but that's only because we go from -10 to 10 and -10 to 10. So this is actually going to be from -infinity to infinity. Okay? Because your x's can go as wide as they want. There's no limitation there. Okay? And then same thing from the range. So the domain is left to right, and then the range is bottom to top. Okay? So this graph can come all the way from -infinity and go all the way up to +infinity. And we always write these in order from least to greatest, so it should be -infinity to infinity. Now, based upon what we already looked at, you should be able to tell the end behavior without having to do plus, minus, or even odd. So is this graph, as we go to the right, because this is the right side, as we go to the right, it's going up, so this would be infinity. And as we go to the left, the graph is going down, so that would be -infinity. Now one time, just to show you what I mean, so this x goes to +infinity, that means that it's the right, because +infinity is to the right, and x goes to the -infinity is to the left. I do just want to show you real quick, plus, minus, even, odd. Okay? So the number in front is +1, which means that should be going to infinity, and the power or the degree is 3, which is odd, so it should have opposite. So this one was going up, so this one should be going down, and that's true. Okay, so let's go ahead and take a look at the next one. We're going to hit y equals and then clear. And then the negative button is down here. If you hit minus, it won't work. It'll tell you you have an error. So negative, and then come back up to that x button, which is next to alpha, x to the 5th power. And then anytime you want to see the graph, you're going to hit the word graph. That makes sense. Okay, so this graph is going like this now. So this one went like this, and this one went like this. Right? So the domain, even though it goes in opposite directions, this side of the graph can go to the left, this side of the graph can go to the right. So that's still all real numbers, and same with the range. However, let's take a look at this. As we're going to the right, the y's are going downhill. So that's -infinity, and as we're going to the left, they're going uphill, so that's infinity. Okay, moving on, y equals x, oh, I didn't clear it, x raised to the 6th power, graph. Oh, that looks interesting. So this graph is kind of doing something like this right here. So this graph, because it goes like this forever, goes up, 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 up forever, the domain, sorry, it goes out, 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 out forever, is negative infinity to infinity. But remember, for the range, I said bottom to top. Is the bottom anywhere down here? No, it starts at 0. So we're going to put a bracket because it can equal 0, because the y value touches 0. If it didn't touch it, then you would put a parenthesis, but it does, and it goes all the way to infinity. Okay, so what is this graph doing to the right? As the x's are getting bigger, it's going to infinity, and same thing to the left. That tells me that the degree must have been even, because they match, right? Okay, negative x to the 4th, so y equals, clear, negative x raised to the 4th power graph. Oh, now this one, so I just want to point something out. This one can have at most 3 turns, because there's 4 minus 1 would be 3, but it's only taking 1, and that's okay, because the rule says that's the most that it can take. It's not the one that it actually has to take. So the domain for this graph can still go out in the left and the right hand direction. We don't see it on the calculator because the calculator is limited, but just imagine if I had a big thing, this would just keep going out, out, out. But for the range, remember, we always do least to greatest or bottom to top. So from the bottom direction, this is going from negative infinity all the way up to 0. So it looks like that. Okay. Now, as x goes to the right, that's what that symbol right there means. That makes sense. Positive infinity is over here for x's. Then the y's are going to negative infinity. And as x's are going to negative infinity or to the left, the y's are also going to negative infinity. Okay? All right, so we are learning how, I should say relearning, because a lot of this stuff you have been introduced to, but we're kind of making all the connections now. So right now we're going to go over 2 more things. They are intercepts. So the y-intercept is when x equals 0. Okay, that should make sense even though it's not intuitive. Y-intercept happens here. So you're going up or down somewhere to find your y-intercept, but you didn't go left or right, and that's why x equals 0. Okay, and then when you want to find your x-intercepts, these are also called zeros, the y equals 0. So it says the value of the polynomial is 0. Another way to say that is just y equals 0. And that should make sense too, because if you're trying to find where it crosses this axis, you're moving left. You might be anywhere on this, so you could be anywhere to the left or anywhere to the right, but since you don't move up or down at all, the y is consistent at 0. Okay? Next thing, multiplicity is the number of times each factor appears. So multiplicity is the number of times each factor appears. So I'm going to give you an example. If I had this function y equals x minus 1 times x plus 2 times x minus 1, the multiplicity, so the number of times each factor, so these are factors. We have a factor of x minus 1, and its multiplicity is 2 because it shows up twice. It seems really complicated, but it's not. And then the x plus 1 factor has a multiplicity of 1 because it just shows up one time. Okay? Most of the time our multiplicity is 1, but it sometimes ends up being 2. And if that's the case, if it is different, then we have different things that happen. So if the multiplicity, the number of times each factors appear, is even, like this guy, then the graph bumps the x-axis there. And if the multiplicity is odd, it's just going to cross through. So let me show you a picture of that real quick in the graphing calculator to make it hopefully make more sense. So I'm going to type this in, x minus 1. You don't have to do this, just watch. Okay, so it's into the calculator and I hit graph. So if you look right here, this is -2, which corresponds to this intercept. So remember, if we're finding intercepts, y equals 0. If I set this equal to 0 and solve, I get x equals -2. So right there, that only showed up once. So do you see how it crosses right through? Versus x minus 1, if I set that equal to 0, I get x equals 1, which is that right there. And it comes down and it doesn't cross through, it turns around. That's called a bump. It's almost like that brick breaker game where it hits the wall and bounces back. This would be going through the wall, this would be bouncing back up. Okay, so again, if the multiplicity is even, it's going to bump, and if it's odd, it's going to cross through. We do these more than we do these. Alrighty. A lot of info, so now we're just going to start graphing these things, and we try and keep it fairly simple for you. So let's take a look at this real quick. Write-in behavior. So for this test, you actually will not do this part on the computer. Your test is 2 parts, so it's going to be part of it, most of it actually is on Illuminate, but then you have a second sheet of paper. So if you need help, tomorrow's a review day. Then you can come in after class, even at lunchtime, and we can start hashing this stuff out. Okay, so let's first, for this one, find our first term. So x times x times x equals x cubed plus a bunch of other stuff. Okay, you're like, all right, I'm going to put my 1 here, and then for write-in behavior, that's plus minus, left-in behavior is even odd. Okay, this is a 1, so that's positive, so that's this. So it's going to infinity. Alright, this is a 3, which is an odd number, and odd is opposite. Okay, so this is going to be negative infinity. Alright, no problem. X-intercepts. What did we say about the x-intercepts? We said if you want to find the x-intercepts anywhere on that x-axis, that tells us that y equals 0. New pen. Okay, so if y equals 0, this is what we're going to do. We're going to take that, which we know is another name for y, and set each one equal to 0. So you definitely did this kind of stuff in Math 1 and Math 2, but we're refreshing. So there's something called the zero product property that says when you're multiplying 2 things together, if the solution or the answer is 0, then either one of those factors had to be 0 or both of them. Okay, so what we just do is we take each factor and set it equal to 0. Okay, and then we solve it. So our first x-intercept is 3. So on a graph, that would be 3, 0, which is right there. Our second x-intercept is -2. That's there. And then our third x-intercept is going to be 1. Alright, next thing I want you to do real quick is look and see if any of these multiplicities are even. So this one shows up once, this one shows up once, this one shows up once. So that means that there are no bumps in this graph. Everything's going to cross through, which we like. Now for the y-intercept, again, you have to, like, if you can't remember, you can usually, so you're like, okay, y-intercept, draw your graph, it's on here somewhere. What is the one consistent thing? Is that anywhere on here, your x-coordinate is 0. So this is what we do. We plug in 0, because this says here's the x, and it's going to be 0. So we get 0 minus 3 times 0 plus 2 times 0 minus 1. That's negative 3, 2, and negative 1, which is going to be positive 6. So this is going to be the x is 0, the y is 6. Alrighty, so there we are with that. How the heck do we finish graphing this? Well, right-end behavior is infinity. So go to your dot that's furthest to the right. That's this guy. And almost draw a straight up arrow. Don't make it go off to the side because it's not how the graph behaves. And then this is left-end behavior. So we go to the leftmost point and we go down. Okay? And then remember, this graph can take 2 turns and it's crossing through on all of these. So in order for it to connect with a smooth curve, it's going to have to do that right there. Okay? So if it's not exactly perfect, it's okay. If you made it the top of the mountain go through the point, that's fine. These look intense, but once you get the hang of it and break it down, it will be easier for you. And if you're not having good luck with these, then you just need to do more. So you need to come in and get a mini lesson or rewatch this video, pause it, try a problem, see how far you can get, unpause it, and see if you can go further. Alright, so step 1, I get this, and it says right-end behavior, which means I need the first term. So I'm going to multiply all these together. Ooh, that's 1, 2, 3, 4 x's. So this is x to the 4th. Right-end behavior, plus minus. Left-end behavior, even odd. The number in front is the 1, which is positive. So to the right, once I find that point, this graph is going up. This number right here, 4, is even. So it's going to matchy-matchy. Think of the E as exactly the same. Okay, so O is opposite and E is exactly the same. So to find our x-intercepts, we set the function equal to 0, or y. Now, the rule about that zero product property is that each factor, so everywhere you have multiplication, so we have 1, 2, 3, 4 factors, and I'm noticing that their multiplicities are all 1 because they only show up once, but I should have 4. So the first one is x equals 0. The next one is x minus 3 equals 0. Then x plus 3 equals 0, then x plus 2 equals 0. Okay, so when you get x equals 0, the point is, remember, the y was already 0, and you just found the x to be 0. So it's right there. Add 3 to both sides. So that's going to be 3, 0. Subtract 3 on this guy. And then subtract 2, because we know how to solve equations by using the inverse. Okay, so I'm just going to plot all these points. 3, 0, negative 2, 0, and negative 3, 0. Okay, and then we need to find the y-intercept, which means that we plug in 0. So then we go 0 times 0 minus 3 times 0 plus 3 times 0 plus 2. And just in case, I'm just plugging it up into this equation because that's the one we're working with. So I get 0 times negative 3 times 3 times 2. 0 times anything is 0, so don't let that trip you up. So this is 0, 0. Here's a little tip. Anytime your x-intercept is 0, 0, your y-intercept is always 0, 0, so that's the same point. What are we doing to the right? We're going up. What are we doing to the left? It's matchy-matchy. So remember, these guys cross through everywhere. So you can kind of see it's going to have to do that in order to get through and make a smooth graph. Okay? Alright, the next one is the last one where we're fully graphing, and I think you guys can get this pretty easily. We do have to make a B right here because right away I want to remember I see that as a bump. So what I want you to know though is that you have to be careful when finding your first term. So if you see a square or a cube on one of the factors, then you should write it all the way out. Instead of writing it as 1, write it as 2, because here we have negative 1 times x times x times x times x, which is negative x to the 4th. So that negative in front does get counted in this. Alright, so we have plus, minus, even, odd. Okay, so the number in front is negative 1, which means that's negative. So this is going to go to negative infinity. And then this right here is a 4, which is an even number, which means it's exactly the same as the right. So that's negative infinity. Alright, find our x-intercepts. Guys, how cool is it that you can graph these? I know it's not your mostest, favoritist thing in the world to do, but it's kind of neat that you can graph such a big equation. And kind of like a shortcut, could you imagine if you had to make a table and plot points for these? That'd be crazy. Okay. So, like we said before, this is really 0, or a negative 1 right there, and you're going to set each piece equal to 0, each factor. So I get 0 equals negative 1. That's false, so we're not even needing to look at it, okay? I'm going to put that third one down here, or the fourth one I should say. So I get x equals 2, and then that's the same thing. So I'm going to put a B there to remind myself to bump or brick breaker it, bounce it off the x-axis and not to cross it through. Then I have negative 1 and negative 3. Okay, so I have 2, 0, negative 1, 0, negative 3, 0. And then I'm going to do f of 0. I don't want to do the square like that. I don't think that's what's best. I'm going to keep using that equation right here, where I wrote it out just to save myself the possibility of making more errors. 0 minus 2 is negative 2, 0 minus 2 is negative 2, 0 plus 1 is 1, 0 plus 3 is 3. So I have 1, 2, 3 negatives, so I know this is going to be negative. 2 times 2 is 4, times 1 is 4, times 3 is 12. So this is negative 10, so that is 0, negative 12 down there. Alright. Whew! Okay, where is that bump? It's going to happen right there. I'm going to put a B there, right at 2. So it is falling to the right, it's falling to the left, and it brick breakers, so it just turns around there, but these guys cross through, so that's what the graph looks like. Okay, so again, the bump is like it comes up, touches, and then turn around, versus like the turnaround point is the x-axis, versus here the turnaround point is not the x-axis. It crossed through first, then turned around, then crossed through again. Whew, kind of intense. All right, well, we're almost done. The next couple questions aren't as intense as that. By the way, if you want to know if you graph it correctly and you have access to a graphing calculator, you should be plugging them into the calculator. Some teachers don't encourage you to do that, but I like problem solvers. I want kids, like if you don't know how to do it, but you know how to use a calculator to get it, then I want you to use the calculator and try and connect the dots working backwards, okay? So that's my preference. So please utilize the resources that you have. Okay, so this one says select the graph of the polynomial function. So I just want to remind you guys that this is what it looks like if I write it in expanded form right there. So the two x's go like that, everything else stays the same. So when I multiply this, this would be negative x to the third plus a bunch of other stuff. So just do plus, minus, even, odd. So this is -1, so it's negative. So falling to the right, falling to the right, falling to the right, falling to the right, falling to the right. Okay, that wasn't helpful, but we tried. Next one is 3, which is odd. So that should have the opposite, so that should be rising to the left. Okay, all of these are rising to the left. Great. So what is it actually looking at? Maybe I should look at my x-intercepts. So 0 equals -1 for that first one, and that's false. 0 equals x, so it needs to go through 0, 0. Oh man, all of those are going through 0, 0. 0 equals x, which is the second x. It needs to bump at 0, 0. Right? Because it shows up twice. So it's bumping here, it's bumping here, it's bumping here, and it's bumping here. Ay, ay, ay. Okay, what's my last one? 0 equals x minus 4, so x equals 4. So it needs to go through 4. Okay, this one goes through 3. This one goes through -4. This one goes through 2. What does this one go through? 4. That guy right there. Okay? Next one, we're working backwards. It says to write a cubic function, so that means to the third power, whose x-intercepts are integers, meaning that they're nice whole numbers or negative numbers, and then you're going to assume that your leading coefficient is either 1 or -1. Okay, so plus, minus, even, odd. Let's get that out of the way right away. So I can see this graph is going down to the right. So that means that my leading coefficient should be negative, right? So -1 is going to go there, and then even or odd, this part of the graph is going up, which means it has opposite behavior. So we already know that it's going to be odd, which they told us it's to the third power. Now we just need to find our zeros. So we have x equals 2, no bump, and x equals -3 with a bump. So that means these show up twice. We do the opposite so that we can get x equals 2, so we do x minus 2. And what's the opposite of -3? That's x plus 3. And because it has a bump, it has to show up twice. So our answer in proper math notation would probably look like that right there. If you write it like this on the test, I'm going to give it to you because you have picked up what I put down. All right. Last one, write a fourth degree function. Okay, fourth degree. So that means to the fourth power. So do you see how if I multiplied this previous one, which said to the third power, x times x times x would be negative, we would have a negative x cubed. A fourth degree function in intercept form, that means like this and not written out. Assume that the constant factor is either 1 or negative 1. So we can always do this. This graph is rising, so that must mean that it's got to be positive 1, and it's matching end behavior, so that must mean it's even, which we already know it's to the fourth power. Alright, so next we have our intercepts. So we only have two intercepts. We have one at x equals 1, and that's a bump. And we have one at x equals negative 2, and that's also a bump. So we're going to write 1, because our leading coefficient is 1. And then we have x minus 1 times x minus 1, because it shows up twice and it's the opposite. And then we have x plus 2 times x plus 2. And then we'll clean it up a little bit because we don't need this 1 here. And we can be fancy and write it with squares. Alright, so that definitely was a longer video. So if you needed to take a pause during it and come back to it, that's fine. Congratulations on making through it. The expectation now is that you're working on your worksheet and getting it done. If you need to rewatch parts of the video, that's the nice thing about having a video. So make sure you put yourself in the best possible area for being successful.